Good afternoon or good morning, depending on where you are joining us from today. My name is John Crossan with Health-ISAC. I want to thank you for joining our virtual training session titled Securing Medical Device Infrastructure on a Shoestring Budget. Today's trainers are Matt McMahon and Helen Negre. This is a 3-hour training that will be provided in 2 separate sessions. We'll have 90-minute session today, followed by a second 90-minute sessions next Wednesday, May 27th at the same time, 12 p.m. Eastern Time. Today's training is TLP White. All participants are muted. If you have any questions throughout today's training, please type them into the question box in the control panel. We will try to address those questions after each session if time permits. This training is being recorded. At the end of today's training, we would appreciate you providing feedback in a short survey that will pop up when you sign off from today's webinar. This feedback will help us improve on future events. I'll now turn it over to Matt to begin today's training. Matt?
Well, thanks, John, and thanks everyone for joining us for securing a medical device network on a shoestring budget. The training will look at some security considerations for our primary audience, which will be a small critical access hospital. That's what we're looking to kind of give recommendations to. But if you're dialing in from a larger hospital organization, hopefully you pick up some good pointers there as well. So advance the slide. There we go. So your presenters today, as John said, will be me, Matt McMahon, and also Helen Negre. So both of us, both me and Helen, work for a medical device company. We're cybersecurity experts there, and we're both professors teaching courses in cybersecurity, healthcare, and digital forensics. So the reason why we created this course, we just wanted to, initially when we came up with the concept for the course, pre-COVID-19, we just wanted to offer a free course, for healthcare professionals, IT professionals that are struggling with the resources to be able to secure their infrastructure. So the course will be aimed at, free, open source, or, in some cases, cheap or readily available tools to secure your network. And our goal is really just to kind of share the knowledge. So hopefully you enjoy. The course today, so as John said, it's a 3-hour course. It'll be divided over 2 days. So today I'll start with looking at the general healthcare threat landscape. Then I'll give the presentation over to Helen. She'll cover some basic network security and network monitoring and scanning. My section will probably be a little bit shorter than hers. I want to make sure that she has plenty of time for network security and network monitoring. So as I said, we'll start off kind of looking at the basic healthcare threat landscape, and it's important to do that if anyone has a cybersecurity background and especially works in healthcare. You know that the healthcare threat landscape is a little bit different than other sectors. Most of the data that we'll be looking at, we will be pulling from. So each year Verizon puts out the data breach investigation report, or DBIR. Most of the data, or a good portion of the data that we'll be looking at, will be coming from the Protected Health Information Data Breach Report, which is another Verizon report that pulls 3 years of just healthcare-specific breach data over the course of, as I said, 3 years, which I think it was 2019 that this was released. So it's pretty current and specific just to the healthcare sector. So most of you that work in healthcare, probably well aware, you've taken the classes through your healthcare organizations. Medical information, or PHI, is 10 times more valuable than a credit card record on the black market. You can't turn that off, and attackers certainly can utilize that information to potentially acquire expensive medical equipment, drugs, combine that information with a provider number, file fraudulent claims, and things like that. What's really unique about the cybersecurity threat landscape within healthcare is the insider component, and we'll kind of break down what we mean by an insider. But if you look at across all of the critical infrastructure sectors in the US, healthcare is the only critical infrastructure sector where you're actually more likely to be internally compromised than externally. So 58% of incidents involve insiders. And if we kind of break that down, it kind of makes sense. Anyone that's actually worked in healthcare On the clinical side, so while I'm a cybersecurity and healthcare professional, I also previously worked as an EMT for a number of years, so I somewhat understand a little bit of the clinical side. And working on that clinical side is quite taxing. You're working late nights, long hours, swing shifts. You're working with technology, medical devices that maybe you were never properly trained on, and you're not really familiar with. You're tired. You're trying to enter information. So, and that's probably what's contributing most to here. You see that the top threat here would be errors. So 33% of this would be errors. So, I'm trying to enter information into a system. I enter it wrong, maybe enter it into, the wrong patient's record and someone else is able to see it, things like that. So these are non-malicious errors, just, the user made some error and it caused a breach of data. So next down, 29.5%, just below 30% would be misuse. So this does have a malicious component. So there's some the individual is misusing data in some way. And this could be something as simple as, I'm a nurse or a clinical practitioner, and I'm telling someone else on my staff that shouldn't have access to a particular patient, hey, did you hear about this patient? So obviously that's, another concern. Physical, we'll get into, that's primarily stolen laptops, coming in at 16% of the of data breaches in healthcare over the course of those 3 years. And what's interesting with this graphic that I like to kind of stress is if you look down at the bottom, both hacking and malware. So hacking accounted for 14.8% of data breaches, and malware was just over 10% or 10.8%. Now, if you look at the news, that's pretty much all we're focusing on is malware. And I'll talk a little bit later about some caveats about how that trend is really changing and malware really is becoming much more prevalent. But it's important before we start getting into the next couple presentations, like Helen's presentation on actually scanning and securing our networks, to really understand at first what we're kind of securing against. So important to be cognizant that error and misuse really is outweighing or outranking hacking and malware. But certainly we want to protect against those as well. So if we look at errors, again, if we go back one, error was the top. What does that actually mean? As I said, missed delivery. So I'm typing a record into the wrong report. That's 38% of our errors. Disposal error. So I think I'm properly disposing of either a digital or a paper record, but turns out that that's I'm not actually securely disposing of it. That's 17%. Loss, I just somehow lost the data, 16%. Publishing error typically would be if this were like an academic study where I think I've anonymized the data and then I'm now releasing that data, and it turns out that someone's actually able to non-anonymize that data and be able to get actual information out of it. That would be publishing error. And what's really interesting about this is in a lot of our trainings within hospitals, we focus on how high tech really drove that through meaningful use in the 3 different stages, the drive towards electronic medical records and really the digitization of healthcare. And we think about how that really increased the likelihood that we're going to have data breaches. But of those 3 years, it's interesting to note that 43% of the incidents that they actually noted were still paper records. So if there's any pressure to stay on paper, bring up that statistic that paper is a very likely source of data breaches as well. So data misuse. So again, that required a distinct or malicious motive. It wasn't just an error, but someone was trying to access something that they shouldn't. 66% was privilege abuse, and again, that could be something as simple as a friend or person of interest came into the hospital, and me as a clinical person, I accessed their record when I really wasn't supposed to. I wasn't taking care of that individual. That involved 66% of the data misuse cases, and 21% was data mishandling. So that gets into the very malicious of I'm now maybe selling records to someone outside, you know, malicious outsider, something like that. Physical, so physical is primarily stolen unencrypted laptops. If the laptop was encrypted, we assume that there's no data breach because while they got the laptop, the data is encrypted and they don't have access to it. So you can see in this case, and this is generally primarily what we see a lot, you know, doctor or clinical staff leaves laptop in a car, someone breaks the car window, steals a laptop, whether it's out in the open or in a bag. The nice thing about this attacker is why they did, malicious attacker, why they did break the window and take the laptop, they were nice enough to at least leave the fudge stripe. So they're apparently not a completely horrible person. Hacking. So again, important to note that hacking only made up 14.8% of that 3-year total, with the top 3 being use of stolen credentials. So almost 50%, 49.3 was, you know, phishing, social engineering, etc. And I think hospitals are well aware of this. You know, if you look at the training and education programs around cybersecurity at hospitals, they're regularly, at least the more cyber aware hospitals, they're regularly phishing their employees. So, you know, it seems to be that they're getting that message. 20.9% is brute force. So just trying to brute force, repeatedly attack a password to see if you can gain access. And then 17.9% would be use of a backdoor. So, you know, a backdoor developer, a way to access a, you know, medical device or some piece of technology. Malware, so the one that we talk about a lot, malware. So ransomware was just over 70% of all malware. But again, remember, it's only 10.8% of the overall data breaches recorded in the healthcare sector over the course of 3 years. But, you know, again, we'll talk about some caveats of how that's significantly increasing this year and, you know, potentially going into the future. So those malware caveats. Again, while malware made up less than 11%, there was a report put out by NTT Security. They were a security firm, and they looked at their customer base, and of all of their customers, while healthcare organizations only made up 7.4% of their customer base in Q2 of 2006, the healthcare sector made up 88% of their clients that were affected by ransomware. So again, they were very their healthcare organizations were a very small percentage of their client base, but they were, you know, woefully underprepared to deal with cyber attacks, particularly ransomware. And it was stated that ransomware attacks on the healthcare sector were likely to quadruple in 2020. I don't know if we've quite quadrupled yet, but you know, again, we wrote this course before the COVID-19 pandemic, and that's certainly adding to the issue. There was the H-ISAC recently released a stat of, I believe it was 20 to 30% increase in cyber attacks, specifically on the healthcare sector. And that was not long after a number of ransomware shops were interviewed by a journalist, and they had a number of them had stated, yes, we will not attack healthcare organizations. That would be a horrible thing to do during a pandemic, but you know, it was shown that that was really not accurate. They're still doing that. So if you're not aware, you know, why is healthcare being targeted? Well, one of the biggest factors is hospitals pay the ransom. Case on the right, the Hollywood Presbyterian Hospital paid $17,000 in ransom to get their system released back to them. And it's kind of understanding why that might happen in this industry. You know, there's a need to be online. If the hospital's offline, it's really life and death. If you don't have access to a key medical piece of technology, you know, lives, or even if it's just delayed. If you look at things like the marathon study, how marathons in a particular area and how that increases the amount of time that it takes a patient to get from, you know, wherever they fall ill to the hospital, increases mortality. Cyber attacks, you know, cause the same thing. So it's obviously important to get back online as quickly as possible. And hospitals, you know, largely have less resources dedicated to cyber defense. So whether that's actual individual people, technologies, monetary resources, and we did talk about the H-ISAC stat. So what are some of the key takeaways with all this? Privilege escalation and abuse is definitely an issue. 2/3 of all incidents involved unapproved or malicious use of organizational resources. So again, this was, could be clinical and any staff that, should only have access to a small percentage of cases, but they're able to then get access to either lab results or an EMR record for a patient that they're not associated with. This is really hard to mitigate. Having been someone that worked for a hospital for a number of years, actually securing or monitoring EMR access, to really lock down so that each nurse in an area only has the access to the 6, 8, 10, whatever it is, patients that they have a day. It's really difficult. You need a number of staff to be able to do that. Factor in too to the fact that like 10% of hospital staff or clinical staff largely are agency nurses that are, maybe coming in today because someone's out sick, but they're not going to be here tomorrow. It's really difficult to be able to monitor that access. So besides throwing a ton of resources at it, I don't have a great solution for that, but it is, a big cause of a number of breaches. And one other caveat with that too, if you have your folks that are working in your hospital managing access, if those individuals are on call at night but they're not being paid to be on call, I'm thinking back to when I had a newborn in my house and I was getting called to update access at 2 in the morning, 4 in the morning, and then 4 and then 5 in the morning. Pretty much so every night, and my wife would roll over and give me a not so nice look when the phone kept ringing. If you're, if you might be incentivizing, your IT staff to actually give broader access so that they're not getting those calls at all hours of the night. So just something to consider. Mishandling of data. So this is kind of a cultural solution. Again, this was 16%, almost 17% of data breaches, and this is primarily just nurse A tells nurse B, hey, did you hear about this, family member, friend, whoever it was, that came into the hospital? I can imagine you probably see this at like a small 25-bed critical access hospital in a town where kind of everyone knows everyone else. So when you have someone come in, a lot of the people that are actually patients. So fraud in the healthcare sector, fraud in the US anyway, is the third highest industry or sector, right behind the government sector, and finance was number one. Obviously, because with PHI, as I said before, there's a lot of money that could potentially be made through that. Breach discovery, this was probably one of the more scary stats. Approximately 1/3 of data breaches go undiscovered in the healthcare sector for years. They're completely unaware of them, and another third are going undiscovered for months. So, when hospitals are compromised, a good percentage of the time we're not really aware of it. So. Budget and staffing realities, it's commonly cited fact that CISOs say that 3% of their hospital budget goes towards IT, and maybe 3% of that budget goes to IT security. So we're just really lacking on the resources. And as I said, 10% of hospital staff on average might be agency staff. So these are agency nurses that are floating from your organization to another organization. Your IT staff may be tempted to, enter access as agency staff 1, agency nurse 2, things like that. But you're really not going to have the auditing capabilities if you're not individually entering these individuals into your system. To look at the HIMSS study, 82% of hospitals said that was 2019 that they recently had a significant security incident. 14% that they did not said that they did not, and 4% said that they don't know. But again, if you look at the stats of how often they're actually aware that there's an incident, that could potentially be higher. Legacy systems, so the same report, 1 to 10% of, or 72% of hospitals said that 1 to 10% of their infrastructure or technology is technically a legacy system, so outdated, whether we're talking Windows XP, a legacy Windows server, things like that. So that's a whole different presentation. The 2006 HIMSS study, unfortunately, HIMSS doesn't do like the same questions every year, so you kind of can't see the stats and how they progress, but these were some concerning stats from the 2016 report. I will say that this report surveyed 200 different medical organizations, and a good percentage of them, I think a quarter, were doctors' offices. So, not larger established hospital organizations. So that's why probably some of these numbers are a little bit skewed, a little bit higher based on that medical based on the doctor's office reporting. But again, across the survey base, 14% said that they lacked any antivirus or anti-malware. 20% said they used no firewall protections, and you can kind of see the other stats. But again, those are pretty heavily skewed towards the doctor's offices. Even most of the smaller hospitals now, obviously, are using most of this technology. So that's the first presentation. I tried to end a little bit quick just so I could give some more time to Helen. She has a lot of technical content she's going to be getting into in the next 2 classes. But yeah, so that's our course. We're really looking to kind of give you the current state of cybersecurity in healthcare, especially amidst the COVID-19 pandemic that all of you are dealing with and the associated spike in cyber attacks with that. So with that, I will turn it over to Helen. She'll be doing basic network security, network monitoring and scanning, and then come back next week for the next 3.
Matt, did you want to take any time to answer questions that may have come in before I get started?
Yeah, we should do that too. Was there any questions in the chat?
There are 2 general questions, Matt.
Sure.
One, the first one, will there be completion certificates for continuing education? We will provide those after today's training. Give us a day or 2, and then we'll also provide for next week's training as well, separate certificate. And then the next question was, will the slides be available or shared by email after the training?
Yeah, so we can email out the slides, but we'll also, we are recording this, so we'll be on, I believe we're putting it on YouTube after the fact. So if you have individuals that weren't able to make it to this training, I don't know how we'll do that. We'll probably send out an email or post it on social media, but there will be links to the training after, when it's available.
And one of the other items we plan on doing is taking a kind of capture of the chat and answering any questions we can't get to during these sessions and putting that out there when we email the slides. So the slides may not come until the end of the second session, just so that we can package that all together and send that out to you.
Yeah, and if there is a high volume of questions too, we want to make sure that we get to everyone's questions. So we did throw around the idea, again, if we get a high volume of questions that we can't answer, because we do have a lot of material that we're trying to cover, we thought about maybe doing a third session where it's question and answer. We'll get them back to you in some way. We'll answer all of your questions because I think it's important.
We're always here to answer your questions. You can always email us and we'll be available.
Yeah, on the last slide of the 6th module, our contact information will be up there, so you can reach out via email, social media, whatever. Yep. Great. Is that?
Thank you. That's all the questions that I currently have.
Okay.
Perfect.
Great. I will change to Helen. Let's see. Yes.
All right.
Here we go.
Screen drop down.
Drop off. All right, I think you're up, Helen.
All right, everybody can see my slides?
I can see it.
All right. So basic network security. Now, I will preface this by saying the target audience here, this is a half-hour session where I'm not going to be able to cover everything. And the target audience, that at least that I had in mind when I was thinking of this, was the one IT guy to rule them all, overwhelmed, you're doing everything, you're IT and IS and everything in one person. And so what are the little things you could do that you can implement to have a big impact in security? This is by no means a comprehensive list. And if you wanted to talk about this is a high-level strategy. If you want to talk about more implementation or other areas of strategy, I'm always available to have that discussion. Well, let me get this out of the way. Sorry, the chat window was popping up and blocking half of my screen. So the importance of network security basics, and Matt covered this a lot in his threat report, so I only have one of these slides where it says in the 2019 HIM study that he mentioned, there's a pattern of cybersecurity threats across U.S. healthcare organizations. And quite frankly, I think in the current COVID pandemic times, we're all have become more aware of the targets that healthcare organizations have become. So 22% of healthcare organizations during that survey reported not having a significant security incident over the past year, which means the rest of them did or declined state. Elements of network security. Think of it as basic hygiene. You know, right now we're all pretty familiar with hand washing. These elements are the hand washing of your network. Strong access management. And this is a time where I'll say H-ISAC does have a working group for identity and access management. It might be an area where if you're a member, you can go and have a conversation to get ideas and support this on that topic. Network segmentation, and I'm going to cover a little bit of firewall basics as well. So HIPAA requirements and network security. There is a requirement for segmentation, a requirement for identity and access management, a requirement for logging, auditing, and monitoring, and a requirement for encryption. This doesn't just end in the US. Obviously, there are regulations around the world that have similar requirements and often more stringent requirements. So your first point is going to be strong access management. Secure access points that are remote. Right now, that's a big deal for many organizations. Even if you're a hospital, you have workers that can work from home, and those people more and more often are being allowed to do so. So you need to ensure that they access the network safely and that you have a 100% certainty of who they are. You need a good password management policy, multi-factor authentication, and physical controls to limit access to restricted areas when people are on site. Network segmentation is simple in premise. Every lab should have its own segment. If it is segmented, it will reduce the scope of a problem should something go wrong. So in that way, more segmentation does mean higher security. It's not the end all be all, but it is a fail-safe. You split your network into zones that contain similar compliance needs and have a similar security policy. Here's a graph, or sorry, a diagram of the typical flat network and then a segmented network, and just a kind of breakdown of which color coding of which machines can talk to each other on what parts of the network. And you can see how that would really limit your attack surface. Here's a little bit of a layout of what that would look like in a hospital. So you have your office workers separated from your lab. Each lab has its own separate network. There's a guest network as well. There's a vendor device management network. And you can go ahead and separate it based on your areas of risk. A VLAN is a logical partition of the layer 2 network. Here is a diagram we made to help give you an idea of what the switch would look like. And VLANs are configured on the switch port. IP addresses and subnet masks are configured on the device, on the devices that connect to the switch ports. The VLAN on the switch must match the IP addresses of the device, and multiple partitions can be created, allowing for multiple VLANs to coexist. Here, at this point, I used to have a demo that I would give, but in the interest of time, I found some good demos and information you can pull from YouTube, and I have put them here. So when you get the slides, you can watch them later, because that does take quite a bit of time on its own. Types of firewalls. So this is straight from Cisco. It's pretty straightforward. We have proxy firewalls, stateful firewalls, UTM, and the next generation firewalls. So the next generations, they're going to have, they're going to do more than just packet filtering and stateful inspection. They actively try to block malware and application layer attacks. Sorry. This is more of threat-focused next generation firewalls, which every person who will try to sell you a firewall will tell you about, but it has the advantage of being easier to administrate. You use firewalls to strengthen network security, but you must have a good policy in place ahead of time. Each firewall rule should be documented so that you know what action the rule was intended to do, and you should track how that rule propagates through your network. So you track the rule's purpose, the servers or applications that are affected, the users and devices that are affected, the date the rule was implemented, when it was expired, and the name of the person who added the rule. And then you track to make sure that it is in fact doing what you wanted it to do after the data was implemented. One approach that a lot of people like is to start by blocking all traffic by default, seeing what happens, and allowing specific traffic to identified services one by one. So you can you turn off the faucet altogether, and then you slowly open it up to then decide what is your minimum viable traffic flow. Here are some examples of rules that, or rule schemas that you should be familiar with. There's whitelisting, which would say you are only going to allow these people to go to this website, and that's all they're going to do. That's what they need to do for their job. You can say blacklisting, which you would allow these users to go anywhere except a certain area. You can block and just say, we're not going to allow anything to happen. And you can have certain rules for VPN. So this is only going to take a place for somebody who's working from home. SANS has a firewall checklist you should check out. There's plenty of information on their website as well. And they cover things like anti-spoofing filters, what kind of user permit rules and management rules to use, what kind of alerts to set up, and what kind of logs to set up. The main purpose of a firewall is to drop all traffic that is not permitted as a safeguard to stop uninvited traffic from passing through your firewall. If you place any drop rule, cleanup rule at the bottom of each security zone, and it'll provide a catch-all mechanism for capturing traffic and blocking it. So Here is an example of how to implement that cleanup rule with some screenshots. Part of all of this is going to tie in with change procedures. So you're going to need to, especially if you're not the only person on this network, keep track of what changes you are making, what firewall configuration modifications have taken place, when they've taken place, and what happened. And for that, you're going to need a change procedure that is pretty robust. Everything's going to need to be meticulously documented. There is a certain amount of automation that can take place in firewall configurations that'll help reduce your time and effort to maintain your firewall. Every manufacturer has their own recommendations, and I would suggest working with your manufacturer in that regard. So when working in Windows, you can manage firewalls via the domain group policies. If looking for a configuration management tool, there's a few options, as well as there's a few options in Linux which would be free. And each, like I said, Dell, Palo, every manufacturer will also have an option for configuration across the fleet. So I will stop here and see if we have any questions.
I'm not showing any questions at this time. Just a reminder, if you do have questions, to enter those into the question box on the control panel.
All right, that actually took a lot less time than I was expecting. So network monitoring and scanning is up next. Let me go ahead and unshare my screen and bring up the slides. All right, can everybody see my screen now?
Yes.
Okay.
See it.
So even in small facilities, you will have many devices in one location and very limited staff to monitor these devices. So what do? We're going to cover network discovery, logging formats, and asset management. So with everything, before you plan a trip, you set up a strategy. Network discovery helps you get the lay of the land. So you perform network discovery, querying devices, taking inventory of your findings over time so that you can really get an idea of what you have out there. You try to validate your findings. Are the devices on the network the property of the organization? You can sometimes physically go and validate, yes, this device is here in this lab. There are some devices you're going to have to manually enter. They don't show up on scans, but you can take care of the bulk of these devices on your network when you're performing some network discovery. When you set up logging and monitoring, it's going to be easier if your devices can send data to a syslog server or do event forwarding so that you can best utilize the same. So you should know if your devices on your network have that capability and go ahead and enable it if it does. While you're doing this discovery, it is a good time to see if anything needs to be updated, if anything is nearing end of life, to get an idea of what is your risk landscape. You're going to take the time, you're going to be interacting with the devices on your network anyways, so you might as well populate this log, whatever you're using, with as much data about your device as possible. And then you also have to decide what information is important to the organization and what is the priority of each device. So certain devices, if there's an issue, will have a greater impact to your organization than others, and you should keep that a note of that as well. So your log data should be as structured as possible. You should have logs that have, they're going to come in different formats. They're going to come in with different columns delineating values, and you're going to want to use the common information model to go ahead and solve this. If you're unsure where to start, your SIEM vendor will help you write rules to organize your data. You're going to want to separate and decentralize your log data as much as possible. Decide what is needed from your logs for each device. So you're going to want to do security logs or system logs or intrusion attempts and connections, and see what's available, and then send only the data you need. It is going to be expensive to store your data with some SIEM vendors, so you're going to want to know what you want to store. With that in mind, also, you're going to want to keep the logs as searchable as possible should something go on. If devices are Windows-based, you might be able to use Windows event forwarding. If Linux, use the existing syslog. You can use Splunk, Security Onion, Elk. There are other options. You're going to want to practice end-to-end logging. Log devices to ensure communication with only trusted endpoints. You're going to log your IPs, all of your connections, and you want to log as much information about the devices, what ports are open, how they're making these connections. You're going to definitely alert on large data transfer files, anything that is unusual for that device. Log an event for if USB is plugged in. Log applications set to run on startup. Search for malicious applications. You're going to want to harden your workstations as much as possible, and then deploy a you're gonna want to use a PDQ inventory to deploy a cheap way to manage your endpoints. Correlate your data sources. Use existing logs of security and systems events combined with localhost logs to detect malicious activity. You have to, in order to do this, you're really going to need to know what normal looks like and what abnormal looks like, and then create signatures. You're going to want to, when you're organizing all your data, use unique identifiers. So getting an alert does you no good if you have no idea what it's referencing. Have a unified naming convention across your system. I don't care what you use, just make sure it makes sense to you. For example, here's the core group in the New Jersey location, file server floor 1. Make sure you have network diagrams, knowing where everything is, that your everything is properly labeled, and that you know all the relevant information, MAC addresses, model numbers, serial numbers, license keys. I would also include version number. Back to more on unique identifiers. Once logs are in a central SIEM, queries can be run. You can utilize script to run searches on interesting data and to alert you automatically. Use a dashboard for this data. You're going to want to perform real-time monitoring. Once again, I'm going to say use a dashboard and SIEM tools. You're not going to want to go through all these logs by hand. If you don't like your the dashboard that's provided with the tools that you use, you can use something like SOC Prime. Go and find a dashboard, but use it. And if you're in a really large environment, you can use certain reporting and check-in features that might be useful. SIEMs are complex to set up, but once you have put in that work, they do pay off. You make it easier to monitor all of the diversity in your network with less staff. So then you know your assets. You, as long as you have done your network discovery well and you know what's out there, you can then tell where your bad guys are and what your threats are. And actually, that is the end of my talk. So are there any questions?
I think we have a
We
few.
do have a
Yeah, and
Yeah.
I ended much earlier than anticipated. It's amazing what taking out the demos does.
The first question is on network discovery. Could you talk a little bit about passive discovery tools like Zingbox and Armis?
I can. Everybody has their own preference. I know that a lot of hospitals have had great luck with Zingbox. I know initially I've been doing active discovery network scanning, and then going in and filling in our gaps with manual effort. Someplace like Zingbox has been set up specifically for healthcare and manufacturing to help reduce a lot of this effort. I personally haven't used it, but I've heard only great things. Is there I'm sorry, I have a side note just to our organizer. Is there a way for me to see the chat between the questions that are being asked?
Yep. So you should see that in the chat.
Do you see
Okay.
like the sidebar, Helen?
Correct, where it says audience questions.
Yep. There you go.
Yeah.
Oh, any good references or advice on what events to keep? So I did have a slide on that, I thought, where it said connections, anything like big data transfers, and anything that would be out of the ordinary. So if you're not expecting a particular device to perform large data transfers, you're definitely going to want to set that alert up. You're going to want to set up any kind of resources that would be out of the ordinary. So once you establish your baseline for that device and that network segment, anything that would be unusual would be what you want to log. I keep logs or I used to keep logs for at least 1 year and 1 day, because I find that 1 year tends to be what people do, and then it would be like exactly a year when something would happen. And I found that it was helpful to at least have 1 year and 1 day. The question is, can you tell us who within a healthcare organization is typically responsible for responding to medical device-related vulnerabilities and alerts? Does it fall into the plate of IT or the organizations to build out some type of clinical IT security group? This is a fantastic question. Unfortunately, it does fall to IT in a lot of the smaller organizations. You have the same person that is building the network as the same person that is responding to everything, the medical device related vulnerabilities and alerts. In other organizations, it'll be biomedical engineering, or they have a special kind of staff for maintaining the medical devices. And they would also patch it, or if there's a vulnerability found, then they would remediate it or contact the medical device manufacturer. It does fall into the IT organization's plate, or the organization builds some sort of clinical IT. Matt, would you agree? Do you have anything else to say on that?
Yeah, I'm just trying to think from a medical device manufacturer side, the plethora of individuals that sometimes reach out. Yeah, it can be diverse. I think it's going to vary if it's a larger hospital organization that maybe has a separate security organization, as opposed to that small critical access hospital that you're the security guy, you're the IT guy, and everything else. It's probably going to depend on your organization, but yeah, definitely somewhere within IT, I would say.
Yeah, it's definitely somewhere within IT. Like I said,
you know what? Although that said, working on the engineering and technical side for a medical device manufacturer, we do get a number of calls too that they were flagged that there was an incident from like a third party IT. So that's kind of something to consider too. If you have, if you've outsourced IT to maybe even outside of the country, it's not uncommon to get that call, from maybe India to say, hey, we're alerted of a possible security incident at X hospital. Can you do something about it? And it's like, okay, well, none of that. Obviously, the manufacturer is not on site currently. The IT is, a couple thousand miles away. I guess if you are outsourcing IT, that would be a good consideration of, maybe spin up a plan of, okay, we're outsourcing IT, but what do we do? What do we have for on-site resources? And does outsourced IT have those contacts so that when something does get flagged, they know who to reach out to and how to get on-site support?
So I guess your answer really is there's no standardization in the US. Every organization, every institution deals with it on their own. So the next question is, for standardized naming conventions of medical devices, is there a public standard that can be used, or do most organizations have to figure that out on their own? To the best of my knowledge, there is no public kind of standard or agreed upon way to name your device in your logs. Matt, have you?
Yeah, even at the component level,
Yeah.
if you're involved in the software bill of material process, even the components, they can be troublesome, and you're scanning them and they're coming back with different names, so you're not really able to always line up exactly what the name is. So yeah, that is definitely an issue. I mean, that could potentially, I don't know if that would be good to have in one of the H-ISAC working groups naming convention, but I do know, at least not necessarily for devices, but on the component level, that's something that a number of the working groups for different organizations through the SBOM initiative are certainly looking at.
Yeah, so that's why I had mentioned using a naming convention that works for you, something that would be intuitive to your organization, and then making that kind of the law within your organization. Whatever would intuitively make sense for your network is going to be the best thing for your network right now. And at the point when we have a public standard, we can migrate to that.
And I think a lot of these questions that we're getting to really kind of go to the sense of, what is everyone else doing, and kind of, how do we share information across hospitals? There is a number, I think in the 6th module, I talk about this, but there is a number of information sharing or partnerships out there. Obviously, H-ISAC with a number of working groups and sub-working groups underneath it, where you can reach out and kind of ask these questions. Obviously H-ISAC, was it MedISAO? The Healthcare Sector Coordinating Council has a number of working groups. There's really a lot out there where you can, if you kind of get involved, can ping other hospitals and ask kind of, hey, what is everyone else doing? It may not be the best approach, but at least if we're all rowing in the same direction, at least there's standardization.
Right. There's kind of internal coordination.
Because there is, and once you start getting involved in those working groups, there's a lot of challenges that we're really trying to work through. One of the biggest issues in healthcare cybersecurity is there's not a lot of standardization in a lot of aspects. So we're really trying. Most of the working groups now are really moving towards some sub aspect of healthcare cybersecurity. Trying to find a standardization or a common ground. Whether it's global or at least within one country, how do we standardize? So yeah, that is an industry-wide issue that we're all dealing with.
Are there any other questions?
Yeah, just a reminder, if you do have any questions, to please enter those into the question box on the control panel.
And I would say it's worth mentioning that Matt and myself work for a medical device manufacturer. So if there is some coordination going on between the hospitals, we might not be aware of it. We obviously only know what medical healthcare organizations disclose to us, or what's publicly available.
Yeah, but even with that, there is a lot of good information that you'll get, for being part of like a H-ISAC.
Oh, for sure.
They'll share a lot of that information, and just with the current, situation too with COVID-19, there's, some of the information blasts that have gone out of, the increased percentage of, phishing and cybersecurity attacks, specifically on the healthcare sector. Exactly what type of attacks we're seeing, so you know what to look for preemptively before it hits your hospital. The incidence of COVID-19 has really highlighted how important something like an information sharing organization is.
We have a couple of other questions that just came in. The next question is, can you please describe what would be useful to include in the dashboard monitor for medical devices?
It depends on the device. I would say definitely system events, any unusual logins or login failed attempts, any unusual traffic to these devices. So especially with most of the devices that are out there now have some sort of white paper or other kind of security guidance where they say, okay, these ports are open, you should expect traffic here, the traffic is of this nature. So you have that as part of your baseline information. And if you see something unusual that's not within those specifications, that's something to log and often to block to see what's going on that device. Matt, anything you want to put in?
Let's see, I think you covered most of it. It's tough because, as Helen said, most medical device manufacturers, you have everything from a very small point of care device to a large CT device. So I think doing that initial assessment, where you're initially looking at the device when you're maybe even before you purchased it, when you're just considering purchasing it, and getting a really good sense of what the device is, what kind of data is transmitted, that will help guide, okay, what do I need to kind of track on this device? What do I need to be cautious of? And then really drive all of the other things that Helen was talking about in the last two sessions of kind of how much do I need to coordinate off? Is it a fairly, does the device itself have a fairly secure and robust security posture, or does it really have to be segmented off? And it's tough because you need you need full-time people to be able to just do those types of assessments, but they are extremely valuable if you can do them to really understand what type of mitigations need to be done and what you should be logging and all of that, if you can really understand the individual device and its purpose too. Is it a device that's going to be point of care? Are you going to be using it for a function that maybe it wasn't specifically designed for? Those are all considerations, like home use as opposed to clinical use.
Thank you, Matt. There's a couple other questions here. The next one has two parts.
I see that. So there's these recommendations for software as a medical device setups and recommendations for air gap systems or systems that are intermediately connected to the network. I have no recommendations as far as solutions. So if that's what you're asking for, I'm not here to make any kind of product recommendations in that way. Software as a medical device setups, I have not had much experience with those. Matt, have you encountered many?
It's interesting. I mean, so I worked in service for a number of years for a medical device manufacturer before coming over to cybersecurity. So I kind of have that long list of service horror stories that I think of. So when we think of medical devices, we think of the way that they're designed and kind of should be run, and then we think of kind of how they may actually be run or not appropriately run. So I would just kind of urge you to consider those. So while taking things offline, air gapping them is certainly a good consideration. I guess remember that that the Natanz power plant was air gapped too, and Stuxnet was still able to be brought in. So and kind of consider that in you might have. I mean, we get calls of, okay, there was a a device that was completely air gapped, but it got there was malware that was found on it. How could that possibly happen? Well, if the device is, not connected and completely air gapped, are your users being creative and finding creative ways to, connect the device maybe where it shouldn't be, and that then kind of feeds back into things that you again should be monitoring for. It's not uncommon to have a medical device that might have a Fire Stick plugged into it if it's in a overnight area.
One thing we've definitely seen, and they're not malicious, they're just bored.
Yeah, I mean, if the device has a USB port, someone's going to try to charge their phone on it. It's, those are the things that you don't think of, but in reality, if it's air gapped and it doesn't have any way to receive updates, but you want it to be able to receive updates, how are people going to, how are the IT staff going to get the updates? They're going to copy them, maybe to a USB stick or something else, plug it into the device, and then run the update. So if they're doing that, what else are they introducing when they're doing that? So it's kind of like it's not unlike kind of, being a parent and thinking, how do you, with kids, if I tell you you can't do something, what are you going to do as a workaround to do it? I guess kind of consider those considerations, and sometimes the best laid plans of locking things down if there's a very easy workaround, or are you locking it down really too much, and there is some functional need to have it connected. Yeah, I guess that would be my thoughts.
Yeah, I mean, in the intermittently connected device, it at least can receive updates, which is beneficial. However, you'd have to see what kind of information they're pushing and pulling at that time. So
Great questions.
Definitely. Yep. Yeah, but I mean, so the other part of that question was the software as a medical device setup. So in my head, I'm thinking of software-only devices. I don't know if that is what you're asking about. For software-only devices, the nice part is you can just add it to whatever your regular controlled computer device or server is. You're putting that into your environment on your terms. If this is something else, Matt, the software as a medical device setup, what are best practices?
And I guess I'm looking ahead maybe to the next question, the definition of medical device versus IoT machines. To me, it's the one clear-cut distinction is medical device requires FDA approval, the 510K process.
Right.
So if it doesn't require that 510K process, then we would probably not consider it a medical device, though medical device manufacturers sell a number of products that may not technically be a medical device because of the FDA requirements of a medical device, but they often they still go through the same processes. So that would kind of differentiate the two, between a medical device and IoT, where IoT might just be your watch that you're wearing that keeps track of all of your vitals. It's housing a ton of PHI. But it didn't need to go through that 510K process, although I will say that those two are starting to blur and coming together. A lot of the point of care devices that we're coming out with are starting to be a lot more connected. Your watch may just send data to an app on your phone, but in a lot of cases they might be sending data to is it sending data to a medical device that's then going to give you more glucose or something like that? There's so much interconnection now, and that is probably one of the biggest things that's going to be really an issue, or not issue, but hurdle. It's exciting because there's a lot of functionality that we can utilize with it. If your doctor has access to all of your records and knows that, some of your vitals have been higher lately, why is that? Then they're preemptively calling you. Certainly that could be a good thing, but it also opens up a can of worms to a lot of potential security issues. So it's, and with the new tide of data privacy, it's really a can of worms, and it's going to be interesting. But yeah, the short answer is what the difference is: a medical device, to me anyway, requires that 510K FDA approval, whereas IoT, even though it's probably chock full of PHI, did not require
it. Next question is VLAN segregation enough for a guest network, or should you segregate it onto a different physical network? Ideally, you'd have a different physical network. If that's not possible, you do the virtual. I mean, that's just kind of simple. The virtual network is more cost effective. That's a really long question. Let me see.
One more question that just came in. Do you need to read that to you, Matt or Helen?
Yeah, that's the link join.
Yep.
Network connected medical devices.
So a unique identifier besides MAC address or static IP. That's where we also encountered the issue that we were talking about earlier of the diversity in the device space. We'll talk about this a little bit later when talking about a patch strategy, but it is hard to say universally across the board, this is the identifier you will use for medical devices. You can use MAC address. That tends to work fairly well for most of the devices, at least the ones that are able to be discovered by scanning tools, and then give it your own unique in-house identifier.
You could use most medical devices that they sell. Obviously, this isn't, well, it would work for software only, but you would have to know where to look for it. You know, when you call a medical device manufacturer and you say, hey, I have an issue with this device and we have a contract, one of the first
Serial
things they're going
number.
to say is, yeah, the serial number. I wonder, I mean, that would be unique. I don't know if that would be, but that's also not always clearly, it's usually like a sticker on the front of the device, but like I said, with
Yeah,
software only, you'd have to get access to the software and then click info.
and it's unfortunately not something that would show up in a scan. Usually you'd have to
Yeah, exactly.
actually physically access the device and then find the serial number.
Yeah, so that wouldn't really be helpful.
It is one of those areas that we need to come up with a standardized identifier, but we do not have one that works for all medical devices that are in the field right now. It's a diverse space. Any other
I'm
questions?
not seeing any other questions now. If anyone has any questions, please enter the question into the control panel in the question box.
And if not, if you don't want to ask right now, like I said, you can feel free to email Matt or myself, and we would be more than happy to continue having a dialogue with you, maybe with something that's more tailored to your situation. All right.
This was really great. Thank you very much. Thank you
Thank you.
everyone for participating in today's training. Special thanks to Matt and Helen for providing this complimentary training today. Did have one question that just popped in. Strategies, resources to create good standard monitoring security policies for OT/medical devices using passive network monitoring tools.
I don't even see that question.
It just did pop in. I haven't put it in the chat. I apologize. You should see it pop up now.
So the strategies, whether you're using active monitoring or active scanning or passive monitoring, would still be the same in that you need to identify what's typical behavior for that device and then monitor for abnormal behavior in that device. There are some passive network tools that we are, or passive monitoring tools that we are currently looking at for as far as compatibility for our devices. And the way they usually operate is by learning the baseline of that device, at least the 2 or 3 that we've looked at so far.
Yeah, I don't have any recommendations that are healthcare specific, but there is so in addition to working with, you know, the medical device manufacturer I work with, I help small businesses in my area develop kind of cybersecurity toolkits. And there's a really good resource, GCA Cybersecurity Toolkit for small businesses. And it offers not just some recommendations on tools, but some templates for creating guidance documents, for your employees, how they should, interact with resources and things like that. I will say that it's focused to small business, so it's not really focused to healthcare in any way. But there is some forms in there that you could maybe generalize and make them applicable to you. So that's the GC. If you just Google GCA GCA Cybersecurity Toolkit for small businesses. And that kind of like this training, if you go in there and go into the modules or the toolboxes, it breaks it down. There's 6 different toolboxes or toolkits. Know what you have, so that's how you can. There's some scanning tools there that you can utilize to scan your network, find what you have, update your defenses, tools for creating password vaults, things like that. Phishing trainings. Let's see. Yeah, so a lot of the tools that that the folks are asking about, again, generalizable not to healthcare, but to just small businesses. You might be able to find some of them there.
Perfect. No other questions, so I think we'll end today. Thank you again for everyone, and thank you, Matt, Helen. Just a reminder that part 2 of this training will be held next Wednesday, May 27th at the same time. It'll start at 12 p.m. noon Eastern time. We hope all of you are able to join again next week. And then the final reminder, when you leave the webinar today, a short survey should pop up. We appreciate your feedback that you have by taking that survey. I think it's 4 questions, so it shouldn't take you but maybe a minute to do that. So I hope to see all of you next week, and have a great holiday weekend. Goodbye.
Thank you.
Thanks, everyone.
Bye.